Okay, now we'll talk about the work done by a spring force. If we have a spring with constant force K and the displacement, compression displacement is X, we have the Hooke's force, which is the restoring force done by the spring, which is negative or minus K multiplied by X. This is X. If we need to apply a force, this force will be in opposite direction with the restoring force, which is Hooke's law, Hooke's force. So will F applied will equal to minus F hook. F hook is minus Kx. We have two minuses. This would make them in plus the sign. So our applied force should be Kx in positive value. Okay. The work done by this spring, I need you before to remember that the equation, the mathematical equation, y is equal to ax. If we need to draw it in xy plane, it is just a straight line, and the slope of that line is a. And we have the equation f applied is equal to k multiplied by x. X is the variable and f is the function, which is a force function, depend on x, which is the displacement, and the constant of proportionality is the k constant. So the slope in this case is equal to k, and the area, as we see before, under this curve is equal to work done by the applied force, which is equal to the Hooke's law, but in the opposite direction. Okay, so the work is equal to area. The area for triangle is half multiplied by the base, which is x naught from here to here, multiplied by the height, which is this value. This value is the force at x naught. Okay, this is a changing force. It is not constant force. Okay, F applied is equal to K multiplied by x naught at x naught. We need to put it here. In this case, the work done by this for the spring or the applied force, this work will be equal to half multiplied by x naught multiplied by K x naught, which is the applied force. So the total area or the total work will be equal to half multiplied by K multiplied by squared x. In general, not x naught, I'm talking in general. Pick any x here, and the work between x naught 0 to x here is half K x squared for changing force. Yes. Let us now take an example. If we have this graph, we don't have but anything but this graph. Okay, it is between the force and the displacement x. We need to understand and remember that the slope is equal to k. At the end point of our compression for this spring is 5 meters. We have the forces 10, 20. Under the force 20 newtons, we have compression distance 5 meters. Okay, we need to find the constant K and the work done when the spring is compressed 5 meters. Okay, K is equal to slope. We have the function Kx. So the slope K is equal delta F over delta x. Remember that the slope A is equal to y2 minus y1 over x2 minus x1, which is delta y over delta x. f2 minus f1 over x2 minus x1. Okay, I need to pick this point as f2, as x2 and f2. Okay, let's change that. And this point is x1 and f1. Okay, so I need to compute the slope for this line. the slope, that f2 is equal to 20, x1 f1 is equal to 0, x2 is equal to 5, x1 is equal to 0. So the slope is 20 divided over 5, which is equal to 4 newtons per meter. This is the value of K, the spring constant. Okay, I need now to find the work. The work is equal to area, to this area. This area is area of triangle. The area of the triangle is, as we said before, it is half the base multiplied by the height. But we show that this is equal to half K multiplied by x squared, which is the same the area. Okay, in this case K is equal to 4 as we find it now. X, which is the maximum displacement or compression displacement, is 5. This will give us 50 joules. This is the work done by this spring. Thank you.